Okay, so what we're going to be covering today, applications of linear equations. If you want a little hint, no, not that. Here's a big fat hint for you. Applications is a key word, is a code word for word problems. That's what it means. When you see the word applications in math, just tell yourself, okay, whatever, it's a word problem. Now, an application is exactly what it sounds like. It's, well, here's some actual scenarios where you would potentially need to use this mathematics we've been developing. But in a more general sense, for your purposes, it's going to mean word problems, and there's just no way to jump around that. So applications means word problems. So there it is. Hey, did I lie to you? No. Here is a general strategy for solving word problems. This is actually just kind of a reformation of something called Polya's four-step problem-solving process. Polya was a psychologist, I believe, and he created a very simple method for doing word problems. And it's so simple you're tempted not to even use it, but no, that would be a mistake. You should try your hardest to use it because it is a very effective method. So you don't necessarily have to write these down verbatim. And when we get to the 1332 section of this course, we will look more closely at Polya's four-step process. I can promise you that. So step one, read the problem carefully several times until you can state in your own words what is given and what the problem is looking for. That's huge. If you don't know what you're even solving for or looking for, what is the answer to the problem? What does it even look like? Is it a number? Is it a month of the year that probably relates to a number? You're going to have to make sure you understand what it's looking for and also what it gives you. And then almost always, for our purposes, especially in this section, you're going to let X, or really any variable, you can use Y, you can use Z, you can use W, you can use L or K if you want. You're going to let your variable represent one of the quantities in the problem. It's just that simple. And then if necessary, if you have any other unknown quantities, see if you can write them in terms of X, meaning see if you can exploit a relationship between the variable you're calling X and other things in the problem that you would normally assign a different variable to. But for these problems, we only have one variable linear equations that we can solve at this point. So everything is going to have to be in terms of a single variable at some point. It's got to. Later on, we will remove that constraint for sure. But for now, that's just the way the game baseball go. Next up, you're going to have to write an equation. It's going to have to involve your variable, and it has to model the conditions of the problem. It has to model the problem. So you know what you're looking for. You've created a variable that represents something, probably something you're looking for. You are going to construct an equation involving that variable. What do you think you do with that equation? You solve the bad boy, absolutely. You're going to solve that thing. In fact, that's kind of the whole point of solving the equation, or excuse me, setting it up. In fact, solving the equation is just your way of reasoning through the problem and trying to figure out the numerical value that makes sense. So solve the equation, answer the problem's question. Now make sure that the solution you find works in the original context of the problem. So if you're solving a problem later on in the semester, and it asks you for your house payment on if you were to buy a $200,000 house with so much down payment, your interest rate is 4%, and you end up with a house payment of 23 cents per month. Wait a minute. I mean, that would be nice. I think we could find that between our couch cushions and pay our rent each month or our mortgage, but that's not going to be it. Or if you solve and get a house payment of negative $300,000 a month. The bank's paying you $300,000 a month to live in a house there? No, they're not. So you just have to make sure whatever you're solving for makes sense and it's not just a wild number. Don't let yourself be fooled. Remember what you're looking for. Remember what it is you're looking for. So this is a good little strategy. We're going to see it again reimagined as Polya's four-step process. Now, next up, when you're talking about word problems, there are all kinds of keywords that you can use to decide, well, hey, which of the operations am I talking about? Addition, subtraction, multiplication, or division? And what are some keywords for that? Well, the addition, whenever you take the sum, S-U-M, that's a fancy word for the result of upon addition. If I add 2 plus 3, the sum is 5. That's the result. You might see more than, like 3, more than, whatever, the number of things you need. That can also mean inequalities. So this one can be a bit of an inequalities. It will throw you off sometimes. You just have to be very clear what context they're talking about. Increased by, obviously, if you see the word plus, I think that should be a dead giveaway. Dead giveaway. Next up, subtraction. You can have minus, of course, decreased by, subtracted from, difference between, less than, fewer than, depending on context, because that can also mean the less than symbol if you're talking about an inequality. So you got to be very careful of the context here. The result of addition is called the sum. The result of subtraction is called the difference. The difference is what you get. 5 minus 6, the difference is -1. Multiplication, of course, times. 3 times 7. The product is the result of multiplication. It's the answer you get. Percent of a number, that's a big one. We will investigate the percent formula a little bit in this course, and then we will expand upon it in Math 1332, especially when we can use calculators. Calculators are going to make our lives easier. Multiplied by, or even if you see twice, you know, it's twice a number. Twice a number plus 7 is 24, something like that. What's that number? And then finally, if you're talking about division, you're talking about divided by, the quotient, the reciprocal, the dividend. The quotient is the result of division. If I do 12 divided by 4, the quotient is 3. That's the result of division. So that's good and lovely. That's wonderful. Okay, we have a cute little one here. So they say education pays off. Education pays off. So the average earnings of full-time workers in the United States, according to their highest educational attainment. So here, the bars, there's 2 bars for male and female. For those who have some high school and are working full-time, the average female makes $16,000 a year. The average male makes $25,000 a year. For those who have had some college, they tend to make a little bit more than high school grad, maybe because they've met people in college who hook them up or something like that. Associate's degrees, and then you see a nice big jump here in bachelor's degrees. Now, these are just averages. If you are a particularly entrepreneurial person and you decide not to go to college, but you start a super successful business and you're making a lot of money, do you really care that you went to college or not? No. But if that's not for you, not everyone's an entrepreneur. Very few people probably really are at the end of the day. Going to college does tend to have a pretty dramatic impact on your lifetime earnings. It really does. There's all kinds of research that establishes that. One thing to note, though, everyone says you got to have a college degree. Depending on the program you want to go to, yeah, you probably need a college degree. If you want to be a nurse, you definitely need it. If you want to be a doctor, obviously you have to have a college degree, and then you go to med school. But how many of you know how to fix air conditioning in a home? Somewhat maybe, or maybe you're really good at it. If you are really good and you're trained and you have the right certifications and things in a heating, venting, and air conditioning, HVAC, repair, all that, you will probably never be without work the rest of your life. If you're really good at it and you go out there and you try to find work, that is a very, very valuable skill that people will pay you money for. That is absolutely 100% true. And if you're just like a mechanical person, you like not playing with things, but fixing things, looking at them, maybe playing with them a little bit, and you're good at it, you're probably going to have a job the rest of your life. How many of you know how to fix cars? And I mean, fix a lot of different cars. You're pretty good at it, or you can figure it out. You can do some Googling and get it working. Well, guess what? If we had one person raise their hand, maybe there's a couple out there. So all of us who don't know how to fix cars are going to have to what? Pay you money to fix our car, if that's the line of work you're in. So if you're good at HVAC, if you're good at fixing cars, if you're good at welding, there are all kinds of career paths you can go down that don't require a college degree. Now, the cool thing that I like about Weatherford is that while Weatherford does offer traditional college courses, of course, we are a college, Weatherford also has a lot of those types of programs. They have a law enforcement program. That's why you might see some people dressed as police officers on campus. They're actually in training, a lot of them. I believe Weatherford has a firefighting school. Does that sound right? But it's at a different location because they need certain resources that they don't have on this particular campus. So there's all kinds of wonderful programs you can go into. If someone tells you you need a college degree and college ain't right for you, there's other paths you can go down. So what I don't think is reflected in this is, among the some college, you could have people who actually do have advanced training in a field that just doesn't qualify as a college degree. So please, for goodness sakes, if you have a different talent or field, don't feel like you absolutely must go to college. That is a complete, and this is coming from a college instructor who would benefit from more people going to college. And I'm still telling you, do what's right for you. Anywho, I mean, I watched, and this is the last thing I'll say, I'm done with my rant after this. I watched a Disney Channel show with my girlfriend the other day. We just were channel surfing and it was on. It was called like Jessie or something. And the little kid who is like, he's like a genius. It's like a kind of corny cliche. He's like a physics genius or something. He gets a bad test grade because there was a mix up or something. And he's like, well, I guess I'm going to air conditioning school. I'm like, what's wrong with that? You're going to have a job that your people are always going to want to pay you till the end of your days, and you can make decent money at it. So I really hate the stigma people put around good, honest work like that, because it still pays off really well for you. Anywho, but maybe college is for you. So the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. So a male who gets a bachelor's degree on average makes 25 grand more than one who stops at an associate's degree. Now, of a man who goes on to get a master's degree exceeds that of a man with an associate's degree. So if you go that extra level, you're going to make on average $45,000 more per year than someone with an associate's degree. And $45K by itself is a pretty decent full-time job, I would say, especially in Parker County where the cost of living is pretty darn reasonable. 45K can go a long way in Parker County. You know, in San Francisco, a family of four living in San Francisco, California, which is the most expensive, arguably the most expensive place to live in the country, a family of four is considered at the poverty line if they make a household income of something like $110,000 a year. And that's poverty. $110,000 a year in Texas for a family of four is doing pretty good, even though our cost of living has gone up. $110,000 is living a pretty good life. You probably can buy a nice house in a nice neighborhood. You probably have money for nice things here and there. So San Francisco is just wild. 110K is poverty. That's ridiculous. But anyways, I'm really feeling like ranting this morning. I don't know why it is. Something about you guys, you say, Josh, we want more context. We don't just want to do a bunch of stuffy math and numbers and nonsense. And hey, I'm right there with you 100%. How many of you kind of like that, or like, Josh, you need to shut up and move on? You want me to shut up and move on? No, I'm kidding. I'm playing with you. Yeah. Anyway, so on average, you make more money when you get a higher education. That's just an average. That doesn't mean it's always true. Does it mean that you pick a random dude with a master's degree, he absolutely makes 45K more than a random dude you pick with an associate's? That's not what it means. But anywho, if you combine the average salary of all three of these men, they earn $214,000 between the three of them. So find the average yearly salary for men with each of these levels of education. Okay, so let's think. Everything is based around what the associate's degree is making. You notice you have the associate's degree person, but then the bachelor's degree makes 25K more than that. The master's degree makes 45K more than the associate's degree. So if everything's based around the associate's degree, and we don't know what the associate's degree person is making, let's just call it what? X. Heck yeah. Give it a variable. That's what you can do. You could call it S for salary or V for vendetta, whatever you want, but let's just call it X because X is the most common variable out there. So here's what we're going to do. We're going to let, and red's just not a pretty color for this morning. We're going to let X represent the average salary for a man with an associate's. That's going to be our baseline. Now, for the man with a bachelor's degree, we could assign the new variable Y to him because we don't know what his salary is either. That's an unknown. But what should we really do? Exactly. Remember, the bachelor's degree makes 25K more per year on average. And we're just going to call that 25 and just know that all our numbers are in thousands. So instead of saying that Y is the average salary of a bachelor's degree, let's say X plus 25, whatever the associate's degree is, plus 25K. And that's going to be the average salary of a bachelor's degree, of a man with a bachelor's. In a similar vein, we're going to say X plus 45 is the man with the master's degree. So we've already got our variable. We've been going through that little 5-step process. I haven't been formally going through it maybe, but the same idea is there in place. And now let's look at the last piece of information in the problem. Combined, so in other words, if I add up all three of their salaries, they earn $214,000 per year. So let's see if I add the associate's degree salary plus the bachelor's degree salary, which was already X plus 25, plus the master's degree salary, which is X plus 45. What will that equal? Well, yeah, you're combining like terms, which is literally the next thing we're going to do, right? But just at the get-go, this is going to end up equaling 214,000. Okay, so now we have an equation that relates our variable along with some other numbers. If we just solve this equation, boom, we figured out what that variable X is going to be. We figured out what an associate's degree will be. And then we just use the relationship to figure out what the bachelor's and master's degree will make. So what should we do to solve this equation? What's the good first step? That's just what the problem gave us. Well, the problem straight up says combined their three salaries was the 214,000. So if I add the associate's salary with the bachelor's salary with the master's salary, then now we're going to start combining the like terms. Yep. Now I'm going to take this left-hand side. I see I've got 1, 2, 3 X's. And then I can add the 25 and the 45 to get 70. Now let's move this over just a hair. Now let's solve this thing. We got to move that 70 over. You're going to end up with 3x equals 144. Three x equals 144. What else? Well, we would divide both sides by 3. So we need to do 144 divided by 3 to get what we need. You're going to end up with 48,000. Now that ain't a bad amount of money. Now that doesn't mean the second you get an associate, you're going to go get a $48,000 a year job, because you're going to have people who have had an associates but also have been working for 20 years in that field who are going to make more money and drive that average up. So that's not the entry level, but that's good to know. An average of $48,000 per year if you have an associate's degree. It doesn't take work experience into account. So all things considered, the man with an associate's degree on average makes $48K. $48,000. A bachelor's degree, well, a bachelor's just makes $25K more than than an associate's. So if you do the math, on average, a man with a bachelor's degree makes $73,000 a year. Again, the second you get your bachelor's degree, don't expect to go make $73K unless you're in a certain type of job field. That's taking other factors, especially work experience, into account. The longer you work, you expect yearly raises usually. One strategy, a lot of people are really tempted to work for the same company their whole life. And hey, if you like the job and they treat you well and you are making reasonable salary increases each year, you can do that. But a pretty popular strategy in the kind of cutthroat corporate world is that you need to change jobs every 2 to 3 years, because you're not going to get promoted at your current place most likely. You're only going to get a promotion if you find a new job that's looking for a higher level than what you're at. And so that's the only way you're going to get consistent raises and increases in salary over time. So that's something to keep in mind, but that's not always true. Finally, the master's degree makes $45K more than the associates. So don't add 45 onto 73. You need to add 45 onto 48. And it looks like that would be about 93K. Again, go get your master's. You're not going to get 93K out of the gate. You might be able to pull 50, 60, 70, depending on the field you're in. So what did we do? We figured out the problem. We assigned a variable. We figured out there were 2 other things we need to solve for, but because they had a relationship to the original thing we assigned a variable to, we could express them in terms of that variable. Then we set up an equation using the information of the problem. Then we solved that equation. And so we were able to get all this information. So pretty cool stuff. If you want, this is a problem from another time. Maybe if you remember this time when you were younger, you used to not get unlimited text messaging. They'd give you like 500 texts a month, and then you would have to pay a premium beyond that. Now that's from a different time, because nowadays the thought of paying for our text messages probably blows your mind, right? We all send millions of text messages a year, not millions, but we all text a lot, so it's kind of wild. But this is still a good idea for finding the break-even point of 2 competing plans. In this case, we're going to see that you have 2 plans for your texting. Plan A, you have to pay $20 flat no matter what but then you charge 5 cents per text you send. Now, Plan B sounds better. You only pay a flat fee of $5 every month, but then it charges 10 cents per text. So at some point, the fact that you're paying more per text message with Plan B, it's going to catch up to the first plan, and then it's going to end up being worse. It's going to end up being worse after you've caught up with it. So we can already tell from the setup here, Plan A is a pretty good plan if you send a lot of text messages. Because the $20 sounds bad, but if you send way too many, at least you're paying a cheaper rate per text message. Plan B is probably a good plan if you text a little bit here and there, but you don't really care too much about it. And so you can incur that. So let's figure out at what point will the two cost the same? How many text messages, do you need to send each month for the two plans to be equal? So let's just recall here. Plan A is $20 plus 5 cents per text. Plan B is only $5, but then it's 10 cents per text. So just some good little bit of information. How many texts do you have to send in a month to break even on these plans? That's called the break-even point. It's very popular, especially in cost revenue analysis. You're going to look at how many units do I need to sell before I can make up the costs of incurring that many units. Okay, well, let's see. We're probably going to end up setting up an equation. The thing we don't know is the number of texts. We're going to send in a month where these two plans break even. So we should probably let that be the variable, right? Yeah, that's what we're looking for. It's unknown, so we should let it be a variable. When I work these problems, when I do these word problems, I like to literally write out in English exactly what the variable represents so I don't lose sight of things. So we're going to let X represent the number of texts sent in a month so the two plans are even in price. So they have the same price basically total. So let's see, now that we know this, let's do that. Plan A, we can set up a little expression for how much Plan A is going to cost me. Well, it's a flat $20 plus 0.05, which is 5 cents, times what? X, exactly. If I write that, this expression here tells me how much Plan A costs every month based on the number of text messages I send, X. Separately, what would the expression for Plan B be? Exactly, 5 plus 0.1x. You don't need to put 0.10. Now, wait a minute. For this particular problem, I want to know, when are those two plans equal in price? When are they equal in price? I set up, boom, there's my equation right there. Now, if I wasn't looking for that, I don't just arbitrarily set them equal. It has to be right for the context of the problem. But here, that is exactly what I'm looking for. There's a couple things I can do. Let's just make things go negative. It's not the end of the world. I'm actually going to move everything involving my X to the left-hand side. That's usually what you like to do. And now I'm going to need a little more space. All right, so let's see, 0.05 minus 0.1, that's kind of like 5 minus 10. It's going to go negative and be negative 0.05. That's what it's going to end up. What do I got to do next? Yeah, let's get rid of that 20. Whoops. Let's use bright green. Oh, that's not too bad. That's a nice smooth green. So I end up with negative 0.05 x equals negative 15. Now what do I got to do? I got to divide both sides by negative 0.05. And so ultimately I'm going to have x equals. Now, a negative divided by a negative gives you what kind of number? Positive. Very good. So what I'm going to do now, I'm going to do that division. Now, technically, we haven't talked about decimal division just yet. So we're going to take a little preview into the future. What you're going to do is if I'm dividing by a decimal number, I'm going to move the decimal point however many places it takes to the right so that it's no longer a decimal number. If I move the decimal 2 places to the right, well, I also have to do it for this interior number. And then I need to fill in zeros. So what I'm actually doing division-wise, I need more space here. I'm doing 5 into 1500. Whatever the quotient of this, whatever the result of this, is going to be the same to me. It's going to be the same. So 5 into 1 doesn't exist. 5 into 15 is 3. Yeah. And now it gives you 0, but there's still things I need to bring down. So if I bring down this, bring down this, then I'd have a 0 remainder. We will cover decimal division of numbers later on in the semester here, just in a couple of short weeks. But the answer is going to be 300. Now, if you're involved in group texts, and sometimes when you're in a new group text, you immediately mute that thing. And it's very annoying, isn't it? Anyways, if you're involved in a group text, you might send or receive 300 text messages in a day. I know I have a movie group text where we talk about movies. I have another one with some of the same guys, some different guys, where we talk about finance and stocks. I have another one where we talk about all the games we're playing on PC. And so while it's fun, there have been times where I've gone away from my phone for an hour and I come back and I've literally got like 150 missed messages because people are just talking up a storm in the group messages. And I'm not going to go back and read all that. I'm not going to. So 300 is probably just not realistic anymore in this day and age. But if you send exactly 300 texts in a month, plan A and plan B are going to be the same cost to you, the same total cost. If I choose to send more than 300 in a month, which plan should I go with? Yeah, I should go with that first one because after 300, plan A, because the cost per message is cheaper, plan A ends up being cheaper totally, in total. What if I send less than 300 texts in a month? You should use plan B because while it costs more per text, you're not sending so many, and plan B is going to end up being the better plan. This is a very common procedure. This is a very common thing that one ought to do whenever you're analyzing the different kinds of plans you make. You know, Verizon has great coverage, great service, but Verizon's expensive. Verizon, they charge you an arm and a leg. So you better really have a need for it. Otherwise, another service may make sense for you. Now, when I walk out these doors, Verizon is going to have me assassinated for saying that. But anyways, no, I have Verizon. Please don't kill me, Verizon. I'm a loyal customer. Okay. So anyways, I just want to make it clear that I'm just kidding there. Verizon's not going to have me assassinated. They'll probably have me sued, and that's just as scary to me. So, all right. So anywho, This is a pretty common type of problem to do. It's always good to do a cost-benefit analysis. A cost-benefit analysis. Again, we haven't quite gotten into multiplication, division, addition, subtraction of decimal numbers just yet. We've done it with basically whole numbers, and we've talked about decimals a little bit. We will go into uber detail about dealing with decimal numbers a little bit later on in the semester here. So just keep that in mind. We're doing these problems, we're kind of previewing ahead to more math we're going to cover. Technically, how many of you have dealt, though, with multiplication, division, subtraction, addition of decimal numbers? You kind of understand it in its basics. So we will revisit the idea. Your local computer store, which is, again, this is a little outdated. There's computer stores still. There's like Fry's Electronics in Arlington, it's very popular. Your local computer store is having a terrific sale on digital cameras. A digital camera is not your phone. It's a separate standalone device that takes pictures. I know, this is a little bit outdated. I guess there's still some digital cameras. Now, what they're going to do is they're going to give you a 40% price reduction. So whatever the original price of the camera, it's now 40% off. Then you're going to purchase the digital camera for $276. What was the camera's price before the reduction? This is an interesting one. Let's see if we can use our reasoning here. Let's see. Camera costs, what do we say, $276 after 40% off. You got 40% off. It now costs $276. What was the original price? We can put that. Well, let's frame our ideas. What is the problem looking for? What is the answer going to look like at the end of the day? The original price of the camera. That's going to be a dollar value. Okay, that's a good thing to keep in mind. So should we go ahead and introduce our variable now? What should it be? Yeah. And what should it represent? Exactly. So sometimes it is just that easy. Other ones, you have to be a little more crafty with what you assign X to. But here we're just going to say X is the original price of the camera. So hey, let's think about it. Well, we got 40% off. How do I express 40% as a decimal number? Yeah, it'll be 0.4. Because 40% is really the same as 40.0% if you want. When you go from a percent to a decimal, you take your decimal and you move it 2 places to the left. So 40% is the same as 0.4. That's good to know because if it's 40% off, the total discount is going to be whatever 40% of the original price is. So I take 0.4 and I multiply it by X, which is the original price. That's going to be not the original price of the camera, 0.4X. That's going to be how much was slashed off the price. That's going to be how much my discount was in dollars. But then if I do take my original price, which we said was X, and I subtract off the discount amount of 0.4X, what should that equal? 276, exactly. That should equal the amount I ended up paying for the camera after the discount. Again, we'll go into more detail about percents and decimal type matters. Am I ready to solve this equation? Am I ready to get the ball rolling? Pretty much. I'm going to solve it for X, and once I do that, I'll know what the original price was. Now, if it doesn't have a coefficient, what is the implied coefficient here? 1, not 0. If you put 0, That's like saying you have none of these x's, but you clearly have one x if I don't have anything else written. So there's an implied one there. So how am I going to combine these like terms? What will this become? 1 minus 0.4, very good, which will be what? 0.6, yeah. You give yourself some extra. It's a lot like 100 minus 40, but with a decimal. So we're going to end up with 0.6x equals 276. Hey, wait a minute, that makes perfect sense. I got 40% off the camera, which means I still am responsible for 60% of the camera's price. 100 minus 40 is 60. And so all this is saying is that 60% of the camera's original price is equal to 276, which is exactly what it should be, because that's what I'm paying for. So I'm going to end up with 0.6x equals 276. What should I do now? Exactly. I've got some coefficient in front of x equals some number. Just because that number, this coefficient here is ugly, it's a decimal number, it doesn't change what I have to do. If this was 3x equals 276, I'd divide both sides by 3. If it was 0.6x equals 276, I would divide both sides by 0.6. You're going to end up with x equals, now we got to go do the division. We got to physically go out there and do the division, and I did not mean to use Christmas colors. Do I miss Christmas? Yeah. You know what the worst day of the year is? Have I ranted about this before? What is the worst day of every year? The day after Christmas, December 26th. That's correct. All the best holidays are over. The best day of the year is like October 1st, because then you're in October, it's the fall, the weather's starting to get a little cooler. I hate the summer. I was born and raised in the great state of Texas. I have lived in Texas my entire life. I've moved around in Texas. I've visited other places, but I'm born and raised a Texas boy, and I hate the summer. I despise the summer. I hate being hot. I like being in a nice air-controlled room when it's 100 degrees outside and I can play my Minecraft in wonderful, cool peace. How many of you hate the heat? How many of you hate the summer? Okay. How many of you maybe you don't hate it? You'd rather not deal with it, but we all realize it's a part of life in Texas, right? Yeah, absolutely. How many of you like the heat? You like the heat? I'm jealous of you. I'm so jealous of you. I would love to love the heat, but I can't. I just can't do it. It's not natural. So anyways, October 1st is the best time of year because then it's Halloween, and then you get Thanksgiving, then you get Christmas. It's amazing. I love it. October 1st is my favorite day of the year because it is a sign of more favorite days to come. December 26th can go straight to HE double hockey sticks, which is hell. I hate it. I hate December 26th so much. I also hate December 31st and January 1st. It reminds me that I'm getting older. There's a new year. I don't want there to be a new year. I want to go back in time. I don't want to go forward in time. But you can't do it. You can't do it. What does this have to do with math? Nothing. But that's okay. That's what we do here. All right. So anyways, we're doing 276 divided by 0.6. Again, the trick with decimal division, remember there's an implied decimal point here at the end of the 276. I'm going to take, this is called the divisor. I'm going to move the decimal point as many places to the right as is necessary for it to no longer be a decimal number. But however many places I move it to the right, I got to move the interior number as well, and I got to fill in a 0. So now what the division truly becomes is 6 into 2,760. The nice thing is whatever answer I get for this, I don't have to adjust it. I already made the adjustments here. Whatever this answer is would have been the same answer as this guy over here. So I'm good to go once I do this one. Now 6 doesn't go into 2. It goes into 27 how many times? 4, not perfectly though. What's 27 minus 24? 3, bring down the 6. 6 goes into 36 how many times? 6 times. It does so nice and easily. Now I'm tempted to end it there, end it like Beckham because there's a 0. But I can't end it until I'm out of things to bring down. How many times does 6 go into 0? 0 times, but I still need to put that. The answer is not 46, it's 460. And then if I went and did the next step of the process, I would be at a remainder of 0, and there's nothing left to bring down. So I'm good to go. And the camera originally cost $460. If you tried to put 46, you would really quickly figure out you're wrong, because a camera that costs $276 after a discount is not going to start off costing 46 bucks. That doesn't make any sense. So the camera originally cost $460. That's probably about right. And if you're going to go buy a standalone camera and not just a phone that has a nice camera in it, you probably expect that camera to be really good and take much better pictures than your phone could take. And yeah, if you're willing to drop the money, they still sell digital cameras. They're mostly for people who are actually professional photographers who really need that jump in quality. For most of us, if you have the brand new iPhone, the nicer one with the 3 little cameras on it, I mean, that thing takes better pictures than NASA was taking in the 90s probably. So maybe not quite, but that is just interesting how technology works. Very interesting. So we paid $460 for the camera had we not gotten a discount on it. This thing goes the extra mile and it checks your answer. So now that we know the answer is 460, we're going to make sure it's correct. You're going to take 40% of 460, which ends up being 184, and you're going to subtract it off from 460. And you'll see you get the original $276 we talked about, which was the price after the discount. Finally, we can do something that's very general. Notice how there's multiple variables here. So this is the formula for the perimeter of a rectangle. Perimeter of a rectangle. Let's look at it more clearly. If you have a rectangle, you might call this the length. That's a lowercase l. So it's usually better because L's can look like I's. It's usually better to write a little loopy L like that. That's the length of the rectangle. That's a W for the width of the rectangle. The perimeter of the rectangle, I'm going to add the width plus the length. But then I got to add this side as well, which is the same as what? The width, W. And then I also add this side, which is the same as the length, L. So I'm going to do W plus L plus W plus L. So we're not even doing any solving yet. We are literally establishing this formula as correct. And now, wait a minute. I've got 2 W's over here. I got 2 L's over here. I'm going to combine my like terms. 2W plus 2L. So all that, it doesn't tell you in the problem, bless you. Was that a cough or a sneeze? A sneeze, so it's a blessing. I've always said, why can't we bless coughs? You never hear, if you cough, you never hear someone say bless you about a cough, but it's the same thing. It's just a sneeze out of your throat. It's not coming out of your nose. Why can't we bless coughs? Well, you know what? In this classroom, I bless coughs as much as I bless sneezes. And how many of you will join me in this cause? Sure. How many of you will raise your hands here today and say, Josh, we pledge to you that we will bless coughs as we bless sneezes? Raise your hand. Raise your hand. If you're out there in the Zoomosphere, please raise your hand. Everyone in the classroom is raising their hand right now. That's not true, but I'm saying that to try and get them to raise their hand. So we will bless coughs in this classroom. Why? Because why not? You gotta have fun. So anyways, the perimeter of a rectangle then is 2 times the width plus 2 times the length. Pretty simple formula, but it's good to see it. Perimeter is not area. Perimeter is a one-dimensional measure of total length. Area is a two-dimensional measure. All right, so now all we gotta do is we're gonna solve for the length L here. Solve for L. So what we gotta do is we gotta move the 2W over so we can get the 2L by itself to start with. So I'm gonna take 2W away from both sides. In fact, it's the same process. It's just because we don't know what P and W are, we can't physically do the subtraction yet. All I can write is P minus 2W equals the 2L. That's all I can write, and I can't physically do P minus 2W yet. Maybe if I throw some numbers in there, we could talk. I can't just yet. What's the other thing I would have to do to get L by itself? Divide both sides by 2, exactly. So ultimately, you can say, I'm going to write it the opposite way. So my L is by itself on the left now. So the length of a rectangle is the perimeter minus twice the width. And then whatever that is, you do that first, then you divide by 2, which is a little funky because the order of operations makes it seem like division should come first. What's not told to you normally is you do the numerator and the denominator separately, then you perform the division. So that's actually, theoretically, there's supposed to be a parentheses around that, so you know to do it first. But it's an implied parentheses. The only other thing I'll note, you could go further with this one. Now, just like if you add two fractions with the same denominator, you can put them over into one fraction. Here, I'm going to split them up into two separate fractions, which I'm certainly allowed to do. I'm certainly allowed to do that because these would have just combined again into this thing. The reason I did this is because these cancel out. And so you could say that your length is P over 2 minus just W. You could even say it's 1/2 P, 1/2 times P minus W. Just multiply by the reciprocal, so to speak. Okay, any questions on that? Any questions? Any questions?